On page 250, review question 1. Find the gradients of the lines joining 2, 5, 6, 7. Let's try to solve this question locating our points approximately on coordinate plane. 2, 5, x coordinate 2, y coordinate 5. So here it is somewhere. And x coordinate 6, y coordinate 7. So it's somewhere here, the second point is. So we are going to find a gradient of this line. How do we find gradient? Remember the formula, vertical distance over horizontal distance. Vertical distance is seen here. Vertical distance is the difference between y coordinates. It is the difference between y coordinates. Look at opposite sides. It's 7 minus 5. It's the distance between 7 and 5. These opposite sides are the same. 7, 5, 7, 5. They are the same. So horizontal distance is, 7 minus 5. Let me write it right here. And horizontal distance is seen here when we shift it to bottom, 6, 2. The difference between 6 and 2 gives us horizontal distance. So when I write here question mark, it's the same with 6 minus 2. So we are going to get 2 over 4. We'll get gradient is 1/2. In B, let's do something else. What? Without locating points on coordinate plane, let's use what we found out here. Look, 7 minus 5. This gives us vertical distance. What are 7 and 5? 7 and 5 are ordinates of the points, y coordinates of the points. They are 7 and 5. So if this is y coordinate 1, this is y coordinate 2, y1, y2. So it's y2 minus y1. We can generate a formula, actually, y2 minus y1 over. And what is 6 and what are 6 and 2 here? And we obtain horizontal distance with them. 6 and 2 are abscesses. They are x coordinates of the points given. This is first point. If we call 2 x1, 6 will be called as x2. So x2 minus x1. We can generate a formula like this one. With the help of A, we generated a formula. So let's call these points x1, y1, x2, y2. So y2 is 6, y1 is -3. So it's going to be 6 minus, from the formula we have minus, itself y1 is also negative, so -3 here again, over x2 minus x1. X2 itself is -2, it's a negative number, so it is the first number, initial number, so I'm not writing in parentheses. And minus we have from formula coming. And now time to write x1, it's 2. So we get minus is going to be plus. -2, they are not multiplied. They are not next to each other. We do not operate the signs here, but this is subtraction. It's -4. So we get 9 over -4. So better to write negative sign in front of fraction bar or in front of 9, doesn't matter. It's minus 9 over 4. The second gradient. The first gradient is 1/2. The second gradient is -9 over 2. Draw the line x minus 3y equals 6. How do we graph a line? How do we graph a line? We substitute 0 for y and x. X is 0, y is 0. When we substitute 0 for x, we find y-intercept. When we substitute 0 for y, we find x-intercept. In the formula, where we see x, we are going to place 0. 0 minus 3y equals 6. Again, minus 3y I'm going to write. 0 is non-effective element here. Ignoring. Equals 6. So negative 3 will be sent to the bottom of 6. So we'll get y-intercept. 6 over negative 3. Positive number is divided by negative number, it's negative. 6 over 3, it's minus 2. So y-intercept is negative 2 in coordinate plane, on coordinate plane. There's a point if we need to write it, x coordinate is 0, y coordinate is negative 2. That's 0, negative 2. By another word, this is origin. Time to substitute 0 for y. So x will be rewritten, x minus 3. Now we don't write y, we replace 0 with equals 6. Everything else is recopied. 3 times 0 is 0. That's x minus 0 equals 6. So ignoring 0 again, x equals 6. So as a point, if we need to write it, x coordinate is 6 when y is 0. When y coordinate is 0. So where is it? Y-intercept. That's the point, the line crossing x-axis. X 6, 0, by another word. So we draw a line passing through these 2 points. This grid line here is in both directions. It's actually being extended. So this line with grid line is x minus 3y equals 6. So simple. Question 3. Write down the gradient of each of these lines. Gradient, what's gradient? Y equals mx plus c. If we see the form ax plus by plus c, it will not help us much, to determine the gradients directly. So somehow, y should be isolated on the left side, and all the other terms on the other side. Y will be isolated without any other coefficient except 1. So it's going to be written in this form also, y equals mx plus c. Coefficient of x is going to be named gradient. That's so simple. Some problems here are so simple. Gradient is here in this problem is 2. Coefficient of x is 2. Here, m is not 7. It's constant of equation. M is coefficient of x. So the number standing in front of x is negative 3, not 3, negative 3. But now we have similar form to this one I have written before. Y should be isolated, I said. So 3x first should be transferred to the other side. 6y will be kept on the left side. So rewrite. 3x on the right side is going to be minus 3x. We have 12 on the right side. That's positive 12. 6 will be dividing the expression on the right side because it's multiplied on the left, so it's going to divide on the right side. Minus 3x plus 12 will be divided by 6. And when we divide each by 6, minus 3 over 6x plus 12 over 6. Each is divided by 6. 3 and 6 can be simplified. We get minus 1/2 x plus 2 we get. 12 over 2 is 12 over 6 is 2. So gradient, the number standing in front of x is minus 1 over 2. Sorry. And finally, 2y, keep it on the left side again, minus 5x on the left side. On the right side is going to be positive 5x. I don't need to write plus sign in front. And we have 15, that's positive number again. Each should be divided by 2. 5x plus 15 over 2. You can skip this step actually and write this one directly. 5 and 15 will be both divided by 2. 5 over 2x plus 15 over 2. So gradient is coefficient of x 5 over 2. By another word, maybe you can write decimal 2.5. Question 4. Use a graph to solve these simultaneous equations. Can I try first classical way? Look at coefficients of x, 1, 1. They are not opposite signs. Here, we can do what? We can multiply this by -1 to get positive x, negative x. It will be very simple then to solve. Or we can multiply this the first equation by 7. 7 times y will give us positive 7y. Negative 7y, they will cancel each other. I think better idea is multiplying second equation by -1, because we have two negative expressions. By multiplying by -1, they are going to be positive. Let's rewrite the first equation, x plus y equals 5. And multiplying by -1, all terms here will change the signs. Minus x plus 7y equals not -7, but positive 7. When we add them side by side, positive x, negative x, they will cancel each other. Y plus 7y is 8y. That's equal to 5 plus 7, 12. So y equals 12 over 8. By another word, if we simplify by 4, we get 3 over 2. That's actually 1.5. Let me write it in the first equation. You know, the first equation, first or second doesn't matter, but first is very simple. The sum of x and y is 5. Y is 1.5. Let's substitute. So x plus 1.5 is 5. X should be 3.5. So 3.5 x coordinate, 1.5 y coordinate on coordinate plane will be the solution. Now let's try to graph these two equations. First, x plus y equals 5. If we substitute 0 for x, simply we'll get 0 plus y equals 5. Y is 5. In the same way, when we substitute 0 for y, so x plus 0 equals 5, we get x equals 5. X-intercept and y-intercept are both 5. Other expression, equation, x minus 7y equals -7. Let's substitute 0 for x. 0 minus 7y equals -7. Minus 7y, 0 ignoring, equals -7. So y is 1. -7 over -7. This is positive 1. Minus plus 7 over 7 is 1. And when we substitute 0 for y, what is x-intercept? X minus 7 times 0 equals -7. That's x minus 0 is -7. Ignore 0. X is -7. Let me try to figure them correctly as much as I can. X and y coordinates are going to be both 5. The first equation. And the second equation, we get y coordinate is going to be 1. And x intercept is going to be -7. So if this is 5, maybe longer. Is it good? If this is 5, yeah, it's okay. Almost 7. So let's draw the lines. The first line, almost. Oops. I missed the point at the bottom. It's okay now? Almost, okay. And the second equation has what kind of line passing through? -7 on x-axis and 1 on y-axis. The points crossing. So we have an intersection point here. Actually, I had to use what? Millimetric coordinate plane to see exact solution here, but we cheated a bit and found it using classical method. X coordinate is really closer to 5, it's 3.5, and it's above 1. Y coordinate of this point is 1.5. If we used millimetric paper, we would get this point as intersection of these two lines with coordinates 3.5. Let's make it 3.5 and 1.5, which means, you know, x coordinate, y coordinate. X coordinate is the value of x in this system, and y coordinate is you know, ordinate of this point, 1.5. So by another word, it's this solution of y. It's 1.5. Okay, question 5. Find the inverse of each of these functions. X maps 5x. So 5 is multiplied by x. Multiply x by 5. So in inverse function, x will be divided by 5. X divided by 5. By another word, better writing, x over 5 is better writing. X maps x minus 8. So we need to lower the value of x by 8, subtract 8. So in inverse function, we will increase it, x plus 8. That's so simple. Here, we need to analyze this mapping here. X maps 6x minus 4. Let's rewrite the rule here again. X is first multiplied by 6, then subtracted by 4, so y is generated. So in inverse rule, we should start from backwards, not from here. So we won't subtract 4, we will add 4. We will not multiply by 6, we'll divide by 6. So we'll generate y coordinate. So let's write it as, you know, in the form of mapping. X maps, x should be increased by 4 first, then divided by 6. So let's increase the value of x by 4, and division can be shown by notation of fraction. So long bar drawn at the bottom of x plus 4, and then 6 is copied. 6 is dividing x plus 4. This will be mistake. Here, if we write it in this way, x is only divided by 6, or 6 is dividing only x, then this fraction, this division is increased by 4. You must be careful. Here, we need to analyze the rule again. What's applied to x? First, x is multiplied by 3. It's decreased by 5. And finally, divided by 2. Fraction. At the bottom, we have 2. That's dividing by 2. So y is generated. So in inverse rule, what will be applied to x? We should start from backwards again. Don't divide by 2, multiply by 2. Don't subtract 5, add 5, using inverse operations. And don't multiply by 3, divide by 3 to generate y coordinate. Let's write it in the form of mapping. X maps. What will be done to x? What will be applied? Multiplied by 2. By another word, 2x. X times 2, or better writing is 2x. Increase it by 5. So write just plus 5 next to 2x. and divide by 3. Longer fraction bar means division actually, and at the bottom we'll write 3. We had 6 students. Now there are 5. Next problem. W is directly proportional to H. W is equal to 8 when H equals 12. Find W when H is 15. Remember how we were solving. We are writing equation directly with one more unknown. If they are directly proportional to each other, we have a, coefficients. W equals K times H, and we need to find this coefficient here. And let's substitute the given values here. When W is 8, the value of H is 12. 12 is multiplied by K, so on the other side it will be dividing. So, in other words, it will be sent to the bottom of 8. So we can simplify each by 4. We get 2/3. So let's rewrite the equation. W equals 2/3H. 2/3H. That means they are multiplied, 2/3H. Find W when H is 15. So we are going to find W when H is 15. Let's place 15 for H. You can first simplify 15 and 3. Or you can first multiply by 2, then simplify by 3. Remember, 15 is only multiplied by numerator, only by upper number. So 15 times 2, it's 30. And over 3, I'm rewriting. 15 is not multiplied by 15, only by upper number. 30 over 3 is 10. So W is 10 when H is 15. I think we have finished review problems, right? We don't have any other questions. Do we have? Question 6 was the final, yeah, in review. Exam style questions. Find the gradient of the line joining the points 5, -2, 3, 8. We have studied a formula in review. Gradient can be found, which is taught in high school with this formula. y2 minus y1 over x2 minus x1. Let's code these coordinates. x1, y1 are from first point, and from second point, x2, x coordinate 2, y coordinate 2, x2, y2. y2 is 8. Let's substitute now, minus, we have from formula. Y1 itself is also a negative number, so I'm writing -2 in parentheses. Over x2, that's 3, minus from formula again, and x1, it's positive number 5, so rewriting 5. Minus is going to be plus, 8 plus 2 will have, that's 10. And 3 minus 5 is negative result, it's -2. If we divide positive number by negative, it's negative, plus minus is minus. 10 divided by 2, it's 5. So gradient is -5. Complete the table of values for y equals to x plus 3 and draw the graphs. If we substitute -2 for x, 2 times -2 plus 3. Oh, sorry, -2. 2 times -2 is -4. Plus 3, -1. So that's y coordinate actually. -1, 0. Y equals 2 times 0 plus 3. 2 times 0 is 0. Plus 3, it's 3. 1, y equals 2 times 1 plus 3. That's 2 plus 3, 5. Let's find them on coordinate plane. Let me use this 2.03, x coordinate 0, y coordinate 3, the other one 1, 5, x coordinate 1, y coordinate 5, 1, 5. Here it is. 0, 3, it's on y coordinate. 0, because x coordinate is 0, that means it's on y coordinate. So when we join these 2 points, we join those 2 points, is the third point passing through the line? Check it. It's -2, -1. X coordinate is -2. So, oops. We had to maybe gradient. Let's change it a bit. Better way. Oops. It's not well drawn because of handwriting. So -2 should take us to -1 on the graph. It's okay. The line, red line here drawn, is y equals 2x plus 3. On a grid, draw the lines. Next problem. Y equals 3. It's a vertical one or horizontal? Remember, x equals a is vertical line. So that means y equals 3 is horizontal line passing through 3. Y equals 2x. This red line is y equals 3. Y equals 2x. Let's substitute 1 for x. We get y equals 2 times 1, 2. So 1, 2, x coordinate 1, y coordinate 2. Let's find out one more point, which is 0. This is very good. The right for x. 2 times 0 is 0. When x is 0, y is also 0. The origin, 0, 0. 0, 0. And the other point is 1, 2. So 1 takes us to 2. Over here. We'll draw a line passing through these 2 points. Origin and 1, 2 passing through. And the last one, 5x plus y equals 10. Remember, we were finding x and y intercepts. We substitute 0 for x and find out x intercept. So that's 0. 2y equals 10 we get. Simply, we get y intercept is 5. I need to draw it here. So 5. And how about x-intercept? To find x-intercept, we need to substitute 0 for y. So 0 here. 5x plus 2 times 0 equals 10. That's 0. 5x plus 0 is again 5x. That's 10. So 5 times what is 10? 2. So x-intercept is 2. Ladies and gentlemen, here x-intercept, here y-intercept. We will draw a line passing through these 2 points. There can be only one line at most we can draw passing through 2 points. From 2 points at most, one line passes through. Okay, next page. Find the coordinates of the points where the line y equals 3x plus 4 crosses y-axis. To find y-intercept, we need to substitute 0 for x. Remember. So y equals 3 times 0 plus 4. We get y equals 0 plus 4. 3 times 0 is 0. So y equals 4. The coordinates of the point is going to be 0, 4. X coordinate 0, y coordinate 4. Write down the gradient of the line y equals 4x plus 2. It's 4. M is 4. It's coefficient of x. Y equals mx plus c. Gradient is the coefficient of x. The line y equals 2x plus 5 intersects the line y equals 2 at the point P. Find the coordinates of P. So this is actually 2 lines, you know. This is horizontal line. Okay, this is another one line maybe. Y equals 2. So y equals 2. Y coordinate is 2. That means So we can substitute here. 2 equals, we write 2 for y, equals 2x plus 5. Plus 5 on the left side, minus 5. I'm rewriting 2, plus 5 on the other side, minus, equals, on the right side of equality, we have 2x. I'm rewriting. So 2x equals, I'm writing right side on the left now. 2x equals 2 minus 5 is minus 3. Divide both sides by 2. We get minus 3 over 2. So y coordinate is minus 3 over 2. And y coordinate is 2. This is the point. And these are the coordinates of point P. Minus 3 over 2 is x coordinate. Y coordinate is 2. It will be a good idea to sketch them. Please, I want you to sketch it on coordinate plane, both the lines, and try to find this point as a solution. Okay, maybe the last page. Find the inverse function of x maps to x plus 7. That means x is first multiplied by 2, then increased by 7 to generate y coordinate. So that means when we go backwards in inverse rule, x, we don't start, remember, from left to right, but from right side we begin. We don't add 7, inverse operation, we subtract 7. And then we don't multiply by 2, but divide by 2 to generate y coordinate. So let's write it in this notation. X maps what? X, what's applied to x? X will be lowered by 7. So we need to subtract 7 for x. And next, this expression should be divided by 2. So fraction bar I'm drawing to show division. Use a graph to solve the simultaneous equations, giving your answers correct to 1 decimal place. So that means we need millimetric paper, but it will be hard to do it. And question 9, it's almost the same, just with different numbers. You just need to write y equals kx, substitute the values given here. And after finding out the exact equation, you will substitute 9 for x to find y. It's almost the same. Only in question 8, it will be a good idea to use millimetric coordinate plane. In your book, you can find, sketch both the lines finding x and y intercepts. Draw them exactly on coordinate plane. Find the intersection of where do they intersect each other. Find it. Intersection point. Millimetric paper, you know, you can get the coordinates decimal in decimals. So you are going to find, what's it, 2.4, or if it's on the other side, minus 2.4. And on the y-axis, you're going to find ordinate of the point, and it's going to be the value of y. So that means maybe we have, no, not that means, it means, correct 1 decimal place means we have maybe 2 decimal places. So we will round it to 1 decimal place. Looking at 100th digit, we will determine, you know, 10th digit we are going to decide. Please use millimetric paper to solve this system. I can say this is the end of the class. Please try to solve them yourself. When you have difficulty, look at the PDF file I'll create and upload to Google Drive and Schoology. You can check them. All right, everybody. Thanks for joining my class. Have a nice Sunday. I'm wishing you. Stay healthy. Goodbye.